Do you feel the vibes?
So in this section, we're gonna go into a specific type of sequence and series. In section 1, it was just in general about all sequences and series. In this one, we're going to talk about a specific one called an arithmetic sequence and series. An arithmetic sequence is something like, for example, 7, 10, 13, 16, where to go from one number to the next number, you're just adding a constant, right? Plus 3, plus 3, plus 3, plus 3. So it's a sequence in which the difference between successive terms is a constant, and it's called the common difference D. So take a look at this one. Determine the common difference and find the next 4 terms of this arithmetic sequence. What you always want to do, the order here matters a lot, okay? You want to find D, you want to take the second term minus the first term, right? Do you see how like the order will matter in the sign, right? So this will now be D equals 17. So that means, the next two, when I add 17, it'll be -2, then 15, then 32, then 49, and so on, right? So we're just adding the same number. Now, if D was -5, then it would just go -5, -5, -5. Okay. So because there is such a simple term, there is such a simple process, it's so easy to come up with a formula for stuff like this, right? So let's take an example. Let's just come up with a formula ourselves. Suppose A1, the first term, is 5. And suppose D is equal to 2. Now, A1, right, would be 5. So let's just make a list here. A1. A2 would be 5 plus 2. A3 would be 5 plus 2 plus 2, so 2 times 2, right? A4 would be 5 plus 3 times 2, right? And then what would A5? A5 would be 5 plus 4 times 2. And then finally, you would get AN, right? So look at what you notice is in each step, you're like if you're on step number 4, you're adding 3 2's. If you're at step number 5, you're adding 4 2's. So at each step, right? So here it's going to be 5 plus, if you're at step N, how many 2's are you going to add? N minus 1 2's. Okay, N minus 1. So that means if I wanted to write a general form for it, it would be A sub N is A sub 1 plus N minus 1 times D, right? Because wherever you are, you're adding to the first term N minus 1 of your D's, all right? So now this is something that we just need to memorize, right? But again, it's like I do it this way, and then it's like kind of common sense, and the number, we use it so much that it'll just be easy to memorize. Okay. So let's talk about all of the different options of what we will and will not be given. So first of all, let's just come up with the formulas. For the nth term of an arithmetic sequence, what we just found is the explicit formula, all right? And it's this. So with this, okay, I can potentially find, let's say, the 77th term, okay? I could just jump down, or I can find like the 342nd term. We can also, because it's just doing the same thing over and over and over again, write a recursive formula. And the recursive formula will be the following. A1, right? You just give the value. A1 is like, whatever, 5. And then you say A sub N is just the previous one plus D, right? Like plus 2, plus 2, plus 2. Okay, so here we go. Write an explicit and a recursive formula for the nth term of this. Okay, so look at what you have here. A1 is 14. D is 3 minus 14, negative 11. So for the explicit, you have to plug this into the formula. So A sub n is A1, we said that was 14, plus n minus 1 times negative 11. And then you have to like distribute. So A sub n is 14 minus 11n plus 11. So A sub n is 25 minus 11n. Or you can write negative 11n plus 25. There's literally zero difference between those two, right? So now with this, if I wanted to find the 91st term, I could just, boom, jump down and do that, okay? Now, how would we write a recursive formula? We would just say, you have to give the first term, A1 is 14, semicolon. A sub n is A sub n minus 1 plus your D, which is negative 11, so minus 11. Okay? But this one, though, is I can't find, like I can't jump down the list and find 70 numbers down the road, right? I have to find them like one by one by one by one by one. Okay? All right, so here we go. Find the 41st term of the sequence. So I need A sub 41. Okay, what do we have? A1 is 11. D is 4 minus 11, which is negative 7. And if I'm finding the 41st term, then n is 41. So my favorite formula of today, A sub n, is A1 plus n minus 1 times D. So A sub 41 is 11 plus 41 minus 1, negative 7. Plug it in the calculator. Yes, you'll have a calculator for this. Negative 269. It is so straightforward, right? It's almost like insulting your intelligence at this point. Okay? All right, so here we go. How about, can you find the first term if the 44th term is 229? Well, let's see. So we want to find A1. So, again, our favorite formula. Okay? So A sub n, this time, the last one, okay, like the one we're finding is 229 equals A sub 1 plus n is 44 minus 1 times 8. Right? So and then you do the math, blah, blah, blah. A1 is negative 115. Okay, so let's move on to arithmetic means. Okay. So arithmetic means are terms between two non-consecutive terms, right? So consecutive terms are ones that come right after another. But look at this one. The 7 and the 47 are not consecutive, right? They're like far apart. So if you take those two random numbers, all of the others that come in between those two are the arithmetic means between 7 and 47. Okay? And it's like not that complicated to find that, right? Because like you're just like stepping, right? Okay, so let's see. write an arithmetic sequence which has 5 arithmetic means between 6.2 and negative 1.6. So the sequence is going to look like this. You have 6.2 and then 5 numbers, whoa, and then negative 1.6. Okay? That's literally, it comes down to subtracting and dividing by 5. And then if you want to like show your method formally, you're just going to put it into like that, like the Bible that has become like that formula that has become like the Bible for this lesson, right? So n equals 7, okay? A1 is 6.2. AN is basically A sub 7. And you need to find D, right? So, oh my gosh. So A sub n plus, okay, so let's see, negative 1.6, 6.2 plus 7 minus 1 times D. So again, exactly what we said. You subtract 6.2, you get negative 7.8, and then you divide by 6. So D is negative 1.3. Yeah? Okay. So then, to find the numbers, right, it's going to be negative 1.3. So here we get 4.9, and then 3.6, 2.3, 1.0, negative 0.3, negative 1.6. Okay? All right. All right. So in here, right, before we move on to the next page, because this is an arithmetic sequence, right, by definition, each of these differences is negative 1.3. So let me, if I do it this way, the difference is negative 1.3, negative 1.3, negative 1.3, right? For all of these. We call this the first difference because when you take a difference the first time, the first round, it's all negative 1.3. So we say the first differences are the same. Now, so let's talk about what that means, okay? If I were to graph these numbers, remember how we were doing that before to see if it converged or diverged? If this is n and this is a sub n, okay? The first number, let's say, is 6.2. Then you go down 1.3 and over 1. Then you go down 1.3 and over 1. You go down 1.3 and over 1. What does that look like to you? A linear function, right? Okay. Look at how the formula looked for this. Does that look like a linear function to you? Oh my God, that is like y equals mx plus b if you ever saw it, right? So now let's go back a little bit further to here. You know how here I said we can label these A1, A2, A3, and so on? So suppose, just for fun, this time we start with A sub 0. So if this was A sub 0, A sub 1, A sub 2, A sub 3, and A sub n. What's happening now? It's A1 plus how many times D? N times D, right? When you start from 0. Is that right? So now AN would be A sub 1 plus N times D. What if I wrote that like this? ND plus A sub 1. Okay? Is A sub 1 a constant? Is D a constant? Is N a constant? No, that's the only thing that's changing. So would this be the same as y equals mx plus b, it would totally be the same as y equals mx plus b. So the explicit formula for an arithmetic sequence is a linear function. Okay? So now let's go to second differences then. Just kick it up a notch. When you subtract the terms, you get the first differences. Okay? This is exactly what we said before. When it's an arithmetic sequence, we get a linear function. However, when the first differences are not the same, then the sequence is not arithmetic. However, we can take a look at second differences. And guess what? When the second differences are the same, it turns out to be not a linear function, but a quadratic function. How flippin' cool is that? Math is all related, right? So like the levels and the degrees are all related. So now let's take a look at this for a minute. Look at this. The first difference here is 8. Here, 10. Okay, so this is not arithmetic. If it was arithmetic, it would have been 8, 8, 8, 8, 8. This one is 12, 14, 16. However, if I do the second differences, what do I get? 2, 2, 2, 2. Positive 2 because you do 2 minus 1, right? 2, 2, 2, 2. So that means this is a quadratic function. And look, somebody plotted them here, right? And it's not linear. So here, this is n equals 1, 2, 3, 4, 5, 6. Okay, so now we need to come up with the function for this, with some quadratic function for this. Okay, let's see. When n equals 1, a sub 1 is equal to 12. So that point here is 1 comma 12. Is that right? Okay. When n equals 2, a sub 2 is 20. So that's 220. Yep. N is the x. A sub 3 is 30. 3 comma 30. Okay. We want a quadratic function in the form a sub n is an squared plus bn plus c. Okay? So, here, these are your n's. These are your a sub n's. We've done this before in chapter 6. And now we're going to do it again. We're going to plug in each of those coordinates. For the first one, 1 comma 12, a sub n is 12. N is 1. Right? Plus c. You guys remember doing this? 2 and 20. A sub n is 20. A times 2 squared plus b times 2 plus c. Then the last one, 3 and 30. 30 is equal to a times 3 squared plus b times 3 plus c. So now we have a system of equations, 3 equations and 3 unknowns. What can we use to solve this? Starts with an M. Matrix. Let's do it. Let's do a matrix. So the coefficients of this first one are going to be 1, 1, 1, and 12. Remember? Here it's going to be 4, 2, 1, 20. 93130. In chapter 6, we learned all about doing this by hand, okay? But we also learned how to do it using your calculator. So you use your calculator for this. I'll give you the answers for this one. So you use your calculator and you put this in reduced row echelon form because we don't want to make more work for ourselves. When you do that, you get an identity matrix, 1, 5, 6. So this is A, this is B, this is C. So your formula is an is equal to, A sub n is equal to 1n squared plus 5n plus 6. And wouldn't you know it? That's exactly the function that's graphed here. Okay? So look at that. Wow, has math made a full circle from like this? Okay, literally, we have just covered all of the math you've learned since Algebra 1 in these 2 pages right here. Like from this, right, with the linear functions to the quadratic functions to the matrices. This is like all of the math you've learned from Algebra 1 to here in 1.5 pages. Like this is why people love math, right? This is like math nirvana we've reached here. Okay? All right. So, okay. So this was all about arithmetic sequences. What about series? Remember what series is just the sequences but added up. Okay? All right. So 2 formulas we need to remember. This is the first one. You need to remember these 2 formulas. So this is the formula for an arithmetic series. N over 2a1 plus an. But look at what happens here. So S sub n is n over 2 a1 plus an, right? What was the an that we just learned about? An is what? A1 plus n minus 1 times d. Do you remember? That's that magic formula from this unit, from this lesson. So look, this is 2a1 plus n minus 1 times d. So that's just the second formula here. So they're the same, but one is substituted into the other. So when do you use this one? Like if you have a1 and an, you can use this one. If you don't have an, you can use this one. Okay? Okay. So look at this. Find the indicated sum of each arithmetic series. Okay, so here we go. Okay, I have a1, I have an. What's d? 2 minus negative 3 is 5. So what you have to do, what you're missing is n. So first you need to find n. Okay. Always go back to that magic formula. A sub n is a sub 1 plus n minus 1 times d. Okay. A sub n is 157. That's the last one. A sub 1 is negative 3 plus n minus 1 times 5. So what is this? This is 160 is equal to n minus 1 times 5. You can divide by 5 and then add 1 And I believe you get n equals 33. Okay? So, what's S sub n? N over 2, A1 plus AN, 33 over 2, negative 3 plus 157. So this is actually S sub 33 because there are 33 of them you're adding, and it's 2541. So most of the concepts are pretty straightforward. I think the second differences and stuff like those are where things get a little bit more complicated. Okay, 17th partial sum. If it's the 17th partial sum, then we need S sub 17, which means n is 17. I have A1 because that's the first number on the list. D I can always find. In this case, it's negative 22. I'm not given A sub n, right? So in this case, I use that second formula, okay? So S sub 17 is n over 2, 2 times 53, plus n minus 1 times d. Oh no, d is negative 22. Oh, I messed up my n and my d. Oh no! Don't ever mess up your n and your d. So 17 minus 1 times negative 22. We know what n is. It's 17. Oh, 17 over 2. Oh, I was not paying attention while I was writing this out. And then you put it in your calculator. So you see these numbers, they're like decreasing, 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 right? So you know eventually the sum is going to be a negative number, which it is. It's negative 2091. Okay. And here we come into a sore spot between me and the publishers of this book. Okay? There are 2-3 things that I disagree with these publishers on in like Algebra 2 book and this book. This is one of them. Okay. The fact that they use n's everywhere here makes this whole thing very, very confusing. Because what we understand for n to be is the number of terms we're adding, correct? So, I prefer, and most books prefer, to use another letter like K for this, so that n is just the number of numbers you're adding. Okay? So K is, okay, so now you have a list. Okay? This is some list. This is telling you add the numbers starting from the 10th to the 32nd. Add these numbers, right? That's what this is telling you to do. Okay? So starting with A sub 10 to A sub 32. So let's think about how many numbers that is. You're going to start with the 10, right? So it's 10, 11, 12, 13, and so on. So n, the number of numbers you have, is 32 minus 10 plus 1, because it's inclusive, right? Let's think about that. Yes? Right? Yes? Everybody okay with this? Okay. So, how much is that then? N is 23. Okay. Now we have to find A sub 1. A sub 10 rather. That's the first term. Okay? A sub 10 is 10 plus 6, 16. And then the last term is a sub 32, 38. Now, S sub n, the official formula is n over 2, a1 plus an. Okay, n we got was 23. This one, though, is the first term you're adding. This one is the last term you're adding, just like here. All right? So now, this is going to be 23 over 2, the first one, plus the last one, and that will be 621. Okay, so for this one, we're going to write the arithmetic series in sum notation, and the lower bound is given. So that's n equals 6. So what's going to happen is we have to write a sum notation. It's going to be from n equals 6 to something. And in here, we need to find an explicit formula and write that formula for an. Okay? All right. So the first thing we need, right? First of all, d is 0 minus 1, so negative 1. And the first thing we need here is a sub 1, because we don't have a sub 1. What we have here is a sub 6. So we're going to use that formula, and we're going to say a sub 6, right? So let's remind ourselves what the formula is. We're going to essentially use it twice. A sub n is equal to a1 plus n minus 1 times d. Now, in the case of a sub 6, a1 plus, when it's a sub 6, n is 6 minus 1 times d. So here, a sub 6, what is it? It's 1 from the list. A sub 1, and then here, this is 6 minus 1, 5 times negative 1 minus 5. So a sub 1 is equal to 6. Now we use the formula again, right? A sub n is equal to a sub 1 plus n minus 1 times d. A sub n is equal to a sub 1 plus n minus 1, we leave n, times d. A sub n is equal to 6 minus n plus 1. A sub n is equal to 7 minus n. So what's going to happen here now is it's going to be n equals 6. This is going to be 7 minus n, right? And then how about d, right? How big is d? So you can use it again and find that. I'm sorry. Where does it end, right? So if this is 6, where is this one? Well, you can use it again to find it. So negative 13, a sub n, is equal to a sub 1 plus, well, what was a sub 1? 6. N minus 1, what's d? Negative 1. So, negative 19 is equal to n minus 1 times negative 1. Divide by negative 1. So n is equal to 20. Okay, so that is what we have. Okay, another way you can do this to eliminate this part, if you know that this is a sub 6 and d is just negative 1, you could just like manually go back 6 steps, right? That sometimes that's quicker. So like this is gonna be, let's say 2, 3, 4, 5, 6, right? Like that's another way you could do it. Okay, that would eliminate this step. All right, thank you very much.